Hello friend, welcome to the course Multivariate Procedure with R. So you can recall that in the last two lectures we had talked about the cluster analysis, and in the last lecture I have given you the basic concept about the hierarchical clustering. Now in this lecture we are going to implement those rules and those concepts inside the R software using a very small data set. Well, why small data set? Because in this lecture I want to explain you how the things look and how do they work. So if you have a small data set, then you can actually see that what is really happening. But if you have a big data set, then you will get only the outcome. So in order to understand the outcome of a big data set, it is very important for you to understand that what is really happening when you try to execute a command in the R software over a given data set which you know. So if you try to implement the same technique on an unknown data set, then you will have confidence that, okay, whatever I have understood, whatever I had verified, the same thing is going to happen in this case. But because the data is so huge, so I cannot see from my eyes, but I can understand the graphic and the results correctly, and I can make the correct statistical inference. So with this objective, let us begin our lecture. In this lecture, we will consider a small data set. So it is very important for you to understand what I am doing and what is the interpretation. And in the next lecture, I will try to take a bigger data set, but there I will not have an opportunity to explain you in more or with more clarity that what is happening. So this lecture is going to help you in understanding the next lecture with a bigger data set. So let us begin our lecture and try to understand this implementation in the R software. Right. Okay. So in this lecture, we are going to understand the hierarchical classification and its analysis with R software. Right. So there are three packages which are dependent on what you want to use in R to implement the hierarchical clustering. One package here is HCLUSTH clust. This is found in the stats package, and this is used for agglomerative hierarchical clustering. We have another command here, you will see here Agnes, AGNES, which is found in a package whose name is cluster. And this is also used for agglomerative hierarchical clustering. So another command here is DIANA, DIANA, and this is also found in cluster package, and this is used for divisive hierarchical clustering. Right. And then we also have an option to find this agglomerative coefficient and divisive coefficient in this Agnes and DIANA function respectively. Actually, these coefficients measure the amount of clustering structure found in the data, right? And these are actually computed. So they are the coefficient. So you will see that there are a couple of things which I would like to illustrate during the implementation of data in the R software for this concept. And these coefficients values, if they are closer to 1, then this suggests a strong clustering structure. This is how you have to interpret it, and I will try to show you how are you going to do it, right? So in order to understand the contents in the lecture, I would request you that you try to please install these three packages: cluster, facto extra, and dent extend, right, using this command install dot packages. Right, and yeah, sometime you will see that in many books and at different places they are also using the package tidyverse. So that if you wish, you can also install, because that may be needed for further data manipulation, right? But anyway, we are going to use only these three packages. So I request you that you please install them in your computer or laptop, and you just load them, right? So that it is comfortable for you when you try to understand this lecture. So first I try to take here different type of commands which are used, and first you try to understand them, and then I will try to show their output in the R software. I will try to show it to you. So first command here is hclust. So this is about the hierarchical cluster analysis on a set of dissimilarities and method for analyzing it. This is for using in this job. So the command here is hclust, hclust, lust or hclust, and then the argument here is here d, which is a dissimilarity structure as produced by the distance function that you will see later on. That distance is a command to measure the distance of the objects, right? Then you have to decide for the method, that what type of method you are going to use. For example, I had described about single linkage method, complete linkage method, but there are several other methods also. So I have not explained you here, but they are not difficult. So but if you wish, you can use other type of methods also, and you can see here we have different types of methods here. Ward method of Q-type, single linkage, complete linkage, average linkage, MCQT, median method, centroid method, and so on. And then you have to give here about means option for here members, which is equal to here null, or a vector which with a length size of d, right? So that I will try to show you how are you going to use it. And similarly, there is another command here, agenus. So this computes the agglomerative hierarchical clustering of the data set, and this you are going to use as agenus. Inside parentheses you have to write here x, which is a data matrix or a data frame or dissimilarity matrix depending on the value of this argument, because I will try to show you which is the next option. So this here is here a logical flag, and if this is true, the default is actually the default for this command or this similarity objects, then x is assumed to be a dissimilarity matrix, and if this is equal to false, then x is treated as a matrix of observation by variables. Then after that you have to define here metric, which is Euclidean method, and then you have to define here the method, which is here average, and so on. So I will say that beside these things here, there are many more options, but I would strongly request you and recommend you to look into the help menu. Similarly, this here metric, this is a character string specifying the metric to be used for calculating the dissimilarities between observations. And at this moment, we have two options, Euclidean and Manhattan, right? So Euclidean distances are the root sum square of the differences, and Manhattan distances are the sum of absolute differences, right? If x is already a dissimilarity matrix, then this argument will not be used and it is going to be ignored. The next command here is diana, D-I-A-N-A, and this actually computes divisive hierarchical clustering of the data set, and its uses is like this. You have to use the command here diana, D-I-A-N-A, all in lowercase, then here x, which is the same as earlier, data matrix or a data frame or dissimilarity matrix or object depending on the values of this argument, and this is also here the same as earlier, and this is a logical flag. If this is true, then x will be considered as a dissimilarity matrix. If false, then x will be considered as a matrix of observation by the variable. And similarly here the metric also have the same interpretation which we have done earlier, that it can take the value either Euclidean or Manhattan. Right, now I try to use this command over this artificially created data set. So you can see here I'm trying to take here three variables, y, x1 and here x2. So y is a value like here replicated of 1, 2, 3, 4, 5 each equal to 4. C will be replicated value 11 to 20 each is equal to 2. So I'm trying to show you here that okay, that some values are going to be similar, right? So because in 1 to 5, if you are using here the command each, that means each of the number is going to be repeated 4 times. And then in the x2, I'm trying to take here some data vector of the character like as t, f, t, f, and so on. Then I try to create here a data frame. So data frame is created as a data CL, which is created by the command data.frame and y(x1, x2), and then I try to save this data CL as a matrix, right? And let me call it here as a D. And then I try to use here the command HCLUST over this D, right? So this D will find out the distance matrix, and then SC here will apply the hierarchical clustering. And then if you use the command here plot HC, then it will plot the dendrogram. So let us try to first understand how it will look like, and then I will try to show it on the R console. So you can see here this Y here is rep 1 to 5. So you can see each equal to 4. You see 1 is replicated 4 times, 2 is repeated 4 times, 3 is repeated 4 times, 4 is repeated 4 times, 5 is repeated 4 times. Then 11 to 20 each equal to 2. You can see here this is 11, 11, 2 times, 12, 12, 2 times, 13, 13, 2 times, and so on. And then your here is here x2 here is tft f and so on. So this is my here data CL, right? So this is my data frame. Now from this data frame, I'm just trying to show you here this is here a D command dist as dot matrix data CL. It will give you here this thing. Yes, it is difficult to read this value at the moment for you, but I will try to show you it in the R console. You can see it very clearly. The only thing is that you have to understand what it is trying to show you. So if you try to see here, suppose if I try to take here this value, so this is corresponding to here 2 and here 3. So this is the distance between the second and third observations. So this is the distance, right? And so on, all these values, they are giving you the distances. And you can see here this part is actually blank because this is a symmetric matrix. In the distance between x and y is the same as distance between y and x, right? So I will try to show you, but I would strongly recommend you that you try to use this command yourself. Otherwise, this matrix is large, so the computer screen will roll. So when I try to use here the command here SC, and I try to do the hierarchical clustering using the command hclust over this distance matrix D, and then I try to plot it here, plot SC. So you can see here, if you try to do it, then it will try to give you here this type of plot. But before that, let me try to show you about the coefficients which I just talked, right? So if you want to use the agglomerative coefficient, then this can be obtained by that first you try to do the hierarchical clustering using agglomerative approach using the command agenus over this data CL using the complete linkage method. Method is equal to linkage, and whatsoever is the outcome, you try to save it in this HC data CL agenus. This is how I have given the name so that one can understand it. Say hierarchical clustering, data of cluster, and then agenus method, right? And then after that, it will give you a different thing out of which I want to extract the value of the agglomerative coefficient. So I use here the command here $AC with this SC data CL agenus here. And you will see here it will come out to be some value which is 0.89. So as I told you earlier that if this value is more closer to 1, that means this clustering is pretty strong, right? And you can see here this is the screenshot of the same thing. Now if you try to see here, this is here the dendrogram. This dendrogram is obtained by the command here pltree, right? So the same output which you have got here, and then you have to use here the command here cx equal to 0.5, hang is equal to -2. I will try to show you that what are these things. Otherwise, I would strongly request you that you please try to look into the help also and try to take different value of this parameter cex and hang and try to see what happens. Right. So if you try to see here, this is the dendrogram which you have obtained for this data set. This data set. So you can see here these two are similar, these two are similar, these four are similar, these four are similar, and so on. So that is why you have this dendrogram, right? And this is here the heights which I was talking earlier. You can see here this height or this height or this height. You can see that they are different heights, and you can interpret it in the way I told you in the last lecture, right? Now similarly, you can have the divisive coefficient measures also. Just like agglomerative coefficient measures, you can also have a divisive measure coefficient, and they are trying to measure the amount of clustering structure found in the data. For example, if you try to see the value of the divisive coefficient is closer to 1, this means it is suggesting a strong clustering structure, right? So now you can recall that in the earlier lecture I have given you this slide, that how are you going to work with the dendrograms, right? So here each leaf in the dendrogram corresponding to one observation that is displayed here. You can see here this is one observation, like each observation, right? And then as we try to move up the trees, observations similar to each other are combined into branches. So you can see here that as we are moving here, this thing, they are joined by here this branches and so on. And if you are moving here up, that at every stage, for example, this is now club 1, this is club 1, and now both of them are club here at this point and so on, right? So the height of the fusion provided on the vertical axis indicates the dissimilarity between two observations. The higher the height of the fusion, the less similar the observations are. This is how you have to now interpret. Now the next thing comes here, that how are you going to measure that how many clusters are needed. If you try to recall earlier, I had made here these types of horizontal lines to indicate that this will indicate you how many clusters can be created when you try to cut the dendrogram. So if you have this idea that how many clusters would you like to have, then you can identify the subgroups using the command here cut tree. So this cut tree, CUTREE, you have to just be clear, for it is not cut tree, this is cut tree. It is a sort of, say, cut tree like this. So this will cut the dendrogram which is resulting from this command hclust into several groups, either by specifying the desired number of groups or the cut heights, right? So for example, if I say, suppose I want to have only here 4 groups, 4 clusters, so I try to use here the command here cut tree, CUTREE, and then I have to give here this output, which is, what is this output? If you try to see here, this was the output which you had obtained here, right? Of which you had computed the agglomerative coefficient. This is the same thing which is obtained by this command here, agenus. Now, if you try to use it and if you specify here k equal to 4, then you can see here these are the units and these are the here cluster number. It is trying to say here that cluster number 4, cluster number 3, cluster number here 2, and cluster number here 1. So it is indicating now that unit number 2, 3, 4, they are in cluster number 1, 5, 6, 7, 8, they are in cluster number 2, 9, 10, 11, 12, they are in cluster number 3, and remaining are in cluster number 4. But it is difficult to count. So what I can do, that I can create here a tabular data of these values. So I try to use here the command table over this subgroup 4 in which I have stored the data, and you can see here that it is trying to say that in cluster number 1 there are 4 values, cluster number 2 there are 4 values, cluster number 3 there are 4 values, and cluster number 4 there are 8 values. So this is the cluster number and this is the number of values. So that will give you an idea that how the things are working. Now suppose if you want to have 6 clusters, then you have to use the command here CUTREE and the same data set which I have used here, but now k will be equal to 6. So you can see here that it will give me the outcome, and then if I try to make a table, then the frequency table, then I can use the command table over this outcome sub grp6, and then you will see here this outcome will come. So here you have here 1 2 3 4 5 6, these are the cluster number, and these are the number of units. You can see here first cluster has or say cluster number 1 has 2 units, cluster number 2 has 2 units, cluster number 3 has 4 units, and so on. Right. And now you can see here this is the screenshot of the same outcome which I have shown you. So now let me try to show you this outcome in the R software so that you can be more confident. So first let me try to upload these softwares or this library. So I already have installed these libraries. So if you can see here that library cluster, facto extra, and then extend, this I have uploaded here. Now I try to create my here this data set, right? So if I try to take here this data set and I try to see here this thing, so you can see here this is, so you can see here now this data CL is here like this, right? And now I try to use first create here the distance metric. So distance matrix, if you try to see here, it is here like this D. If you try to see, let me try to say, you can see here D will be here like this, right? Or if I try to make it here, it will be here like this, because it's a long value. So you can see here it will go up to 20, and then I have only had up to 10. So this 10, and then the remaining part is here, right? So you can see here, but these are the different values between, for example, this value where I am highlighting, this is the distance between this here third and here fifth value. You can see here this is 1.73 and so on. So similarly other distances are computed. So you can see there it is not difficult to do them. Now I try to apply here the hierarchical clustering. So you can see here this outcome is here like this, right? And then I try to plot here with this here this one. So you can see here this will here like this. You can see here this is the dendrogram which I had shown you, right? So you can see here that it is not a very difficult thing, and you can do it very easily. So now let me try to use here this command, this agglomerative coefficients here. If I try to show you here, so you will see here this is here the, when I'm trying to use the command Agenus over this data set, you can see here this outcome looks here like this, right? You can see here this is agglomerative coefficient is equal to 0.89 and so on, then order of the object, and then there is a summary of the observations and the different types of other information. And if you want to have a similarly here, if you want to know only the agglomerative coefficient, then you have to use the command, and then you have to use here the command $AC, and you will get here the same value which you have obtained here like this one, right? And then if you want to create here this tree here, so the another command which has more options, it is given by here like this. You can see here this is created here, or because it was not there earlier, so I will try to create it once again so that you can see that it is created here. Now it has many options which I would like you to look into the help menu and try to do it here, right? Now if you want to have here, if you want to create here the groups, so you can see here you can see here like this. So the value of here sub grp4, it is here like this. And if you want to make it here, say here 6 groups here, so you can see, let me call it here as a subgroup 6, so that you can store it this one, sub grp6, it is here like this. And if you want to suppose make it here actually, say here 12, so you can see here 12 will be here like this. So just you have to make k equal to 12, and then subgrp, say 12, this outcome here is like this. So you can see here that the number of elements in the clusters, they are decreasing, and that is expected also, right? And yeah, so this is all about this clustering in this lecture. And so now we come to an end to this lecture. Well, there are many more things which we have to do, but my objective in this lecture was basically to give you the idea about these commands and these packages. Now, because I have taken a very small data set, so here using clustering does not make any sense. But as I said in the beginning, my objective is something else. I wanted you to understand that how the outcome is coming and how the things are happening. When you have only here 10 values in one variable, possibly you can see how the things are happening. But when you have, say, this million values and also values in thousands, you can see this structure, but you will not be able to look inside the data to understand it. In that case, you will have to depend on the outcome. Looking at the outcome, you have to understand what is happening inside the data. So once I try to take care a very small data set which you can see from your eyes, then looking at the values, then you can have an understanding that, okay, this value is like this, then this is going to happen. For example, when we try to look at the thermometer reading, by looking at the level of the mercury or the reading of the temperature, we decide whether the person has got a fever or not. So this is the same job which we are trying to do when we are trying to understand the outcome of the R software. So my request to you all is that please try to use this command, try to look into the help menu, because honestly speaking, I cannot explain you here all possibilities which can be done with these commands. And unless and until you try to experiment with different choices, different parameters, it may be difficult for you to understand the whole process. So my request is that please explore this, please practice this, and I will see you in the next lecture. Till then, goodbye.